In this lecture, we're going to see a simple example of how you can use concepts to make your job easier. And what we're going to do is to enforce for things to have an output stream operator. If they don't have an output stream operator, we can't really use them with our functions. And what we have here is an output stream operator, which is going to be printing out a vector of things. This is a non-member freestanding global function, which is going to be printing a const vector of t's, and we are templating on what we store in the vector here. And we are enforcing that what we store in our vector satisfies our output streamable concept. And this concept is going to be looking for the output stream operator. If t doesn't have the output stream operator, we're going to have a constant failure and the code is not going to compile. And a good thing about this is that if you try and store things in your vector and those things don't have the output stream operator here, we're going to have a good error message, which is going to say that this thing is missing and you will know exactly what's wrong here. So let's look at a few examples of how we can use this. For example, we can set up a point class. And we're going to give this an output stream operator, but we can easily take this out to see our concept failure. And we're going to set up a vector of int, and we're going to set up another one for point, and we're going to be printing these vectors using our output stream operator. And this is going to work because we have an output stream operator that can print a vector. So this is going to be picked up by the compiler and used. But what we want to see is that if we don't have this operator here, we're going to see a concept failure and we're going to have a good error message that is going to say exactly what's wrong. At least that's what I hope we're going to get with GCC and Clang. So now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is concept example 1. We're going to grab our template files because I think we don't need any more complicated things here. So we're going to bring this in, we're going to paste in the files, and we are going to crack this open in Visual Studio Code here. This is going to give us our starting point. We're going to clean up a little bit, and we're going to include the concepts header because we need this here. We are going to also include the vector class, and then we're going to put in an output stream operator that can print vectors. But before we do that, I want you to show you the problem that we face here. For example, if we set up a vector of int and call it numbers, and we want to print this out, let's do something like this and say numbers, and say numbers. We want to print this vector here. You're going to see that this is not going to work because we don't have an output stream operator that can print a vector. Let's pass this through one of our compilers. I am going to use GCC because it's my favorite. And you're going to see that this is not going to work, okay? This is not going to work because a vector doesn't have the output stream operator here. You can see that it is missing in this compiler error. So what we can do is set up our own output stream operator that can print a vector. And we're going to make it a function template because we want that to work for a bunch of types. So what we're going to do, we're going to say template type name t, right? And we're going to put in our output stream operator like we have been doing all along. This is going to be a non-member function. It's going to be a freestanding global function. You should know that. So we're going to say std stream reference. That's what we're going to say. And it's going to be operator stream insertion. The first parameter is going to be a stream object, so ostream reference. Let's call this out. And the second thing is going to be a const vector, std vector of t, and we're going to call this collection, or even let's call this collection, no problem. And we're going to make this a reference. I think we don't need copies here. And this is going to be our operator. We can just go in and put in the body for this little boy here. So let's do that, and let's call this vec, and we're going to go in and put in our body. I'm not going to type this out because you already know this. So we're going to be putting out a square bracket. We're going to loop around printing each element in the vector. Then we're going to put a closing square bracket, and we're going to return our output stream operator here. Why do we have this little thing? I don't know why. So let's pass this through the compiler. It's going to tell us if we have anything wrong in here. And you see it was just Visual Studio Code. You see that now we have an operator which is going to be picked up by the compiler. The compiler is going to see that we are using the output stream operator here. It's going to look for any method that can service this requirement we have here, and it's going to pick up this operator and use it. And if we run this, we're going to see that the code is going to work just fine. So the build is good. We can clear. Let's bring up a terminal window. We want a terminal window, so let's do that. And if we run, we're going to see our data printed out. Now the problem is this function template is going to work across a wide range of things, even for things that don't have an output stream operator. Because you see we are looping around printing each thing in our vector, so we kind of require that the T type here has an output stream operator. And we can enforce this using a concept. That's what we're going to do right now. We're going to write our own concept, and again, you know how to write your own concept. If you don't, please come back to the chapter where we learned about C++ 20 concepts. I think we have a chapter on that right here, and you're going to learn all you need to know about concepts here. So here we're going to write our own simple concept. I am just going to go on top here and put this in, and it's going to be called output streamable, and it's going to require that we can print whatever T we have using an output stream, and the syntax here should work. So this is our concept here. Once we have the concept, we can use that in our template declaration. This is one way we can do this. So let's change the type name here to output streamable. Let's go back. I don't know what I just put in here. So we're going to grab output streamable here. We're going to copy this, and we're going to replace that in the place of type name here. And now our output stream operator will require that T is output streamable using the output stream operator here. Now, if we try and set up a vector of things that don't have an output stream operator, we're going to have a concept failure, and we're going to have a nice error message here. Okay, so what I am going to do now is go down and put in a class called point, which is going to wrap around two double members, and it has an output stream operator in, but I am just going to comment that out for the moment. And I am going to go down here and set up a vector of points and call it points. I am going to initialize it this way. This is going to work because this is a struct. And we are going to SDDC out this and see what happens. So we're going to say points, and we're going to say points here. And now if we build, we're going to see that we have a problem here. So what is the problem? No operator stream insertion is available, but if we get stubborn and pass this through the compiler, again, we are building in C++ 20 mode, don't forget that. And if you want to see where we set that up, you can go in our tasks JSON. You're going to see that all these compilers are going to be building in C++ 20 mode. And the compiler from Microsoft, is also using the latest flag, which is going to give us C++ 20. So don't forget that. So we have a concept failure. If we sift through this madness here, we're going to see that our concept is failing somewhere. And again, this is really tedious to sift through these errors. If you want, you can search through this to find your concept failure. But this is what we have to work with now. So this is how we can enforce that our type satisfies a concept to make the error messages we see much better. So let's go in and make sure that our point class has an output stream operator. We can do that right here. And now if we build, we're going to see that the compilation is going to go through. You see the build is good. If we bring up a terminal window and run Rooster, this is going to work. We're going to see our point vector printed out. And this is my little example to show you something a little bit fun you can do with concepts. But of course, you can do much more complex things using concepts. And I am sure that as you use them with time, you're going to get better at doing very complex things with concepts in C++ 20. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see another example. Go ahead and finish up here and meet me there.